Hello guys, this is Josh and I'm back um, to solve this Leetcode problem 253 called meeting rooms 2. This is the evolution of the problem meeting rooms. So if you haven't solved that one, I would recommend you go and check that out. Check one of my videos about meeting rooms. There are actually two solutions for that one. Um, you can even solve it in different ways. I would recommend you go there and checking that out. But this one is also one that shows up a lot on interviews, so I would like to give it that one. This one to try. All right, so let's start. Okay, so what is the problem? Okay, so given an array of meeting time intervals consisting of start and end times, find the minimum number of conference room required. So let's take a look at the example, right? So the example has a start time of 0 and an end of 30, a start time of 5 and an end of 10, and a start time of 15 and an end of. So basically what he wants to know is how many simultaneous meetings do they have? Why is this an important problem? This is a very practical problem that you could have in your company. Um, Basically, they want to know, like, let's say that you're in a co-working space and you want to, your company has a co-working space and you want to know how many meeting rooms you need to rent, right, at any given time to support all of your meetings throughout the day, right? So here you have 3 meetings during the day. So maybe, do I really need 3 meeting rooms? Maybe yes, maybe not. Let's check that out. So we have one meeting that starts at 0 and ends at 3. So this is 1. Let's have our counter here, okay? 1. And then you have another one that starts at 5. And this one has not ended yet. So then this one, this counter goes to 2, right? And then you have your next meeting starts at 15, but this last one is over. So that means that when this one starts, you only have 1 meeting. So then your counter kind of stays at 2. So then the answer is 2, and as you can see here, the answer is 2. So this is the problem that you have. So how would you solve this? One way to solve this, so one way to solve this is I would first, the logical way to look at this is that I would start by sorting my meetings by start time, right? So then I'll sort my meetings by start time. And then based on whenever the meetings start, I also want to keep track of their end time. But I can't really have another list sorted by end time because I can have a meeting that ends before one starts. So that doesn't work. So what we need here is another data structure. And the one that comes to my mind is a min heap with a priority. We're going to use a priority queue that is implemented by a min heap. Priority queue, it's nothing more than a list that on top of having a order of the elements also has a priority. So it's always going to return the elements that has the highest or lowest, depending on how you look at it, priority. And if two elements have the same priority, then they're gonna be returned uh, according according to their place in the list, right? So, so what do we do here? So first we sort by start time, and then we need a counter like we have here. So let's call this max meetings. Well, let's call this meetings happening. It needs an integer, right? And then we need to create a priority queue. We need to create our priority queue and add the first meeting to it. Remember, we're gonna add the meeting. Let's just say here that the end time sets the priority, right? So then we're gonna loop through our meeting list, starting with the second one. Why starting with the second one? Because we already have the first meeting in our priority queue, right? And then what we're gonna do is that we're gonna check the end time of the meeting on top of our priority queue is less than the starting time of the current meeting. Then we just pop the meeting off the queue, right? So if it is, if it's not, we don't need an else here. So when we are outside that if, then we add the current starting meeting to our queue. And here we compare what is higher, the current counter or the current counter or the length of the queue. Because if the current counter is less than what we have in the queue, that means that we need to pop that, right? And then we just return the counter. So I think this will work. So for example, we're gonna sort this already sorted by start time. So let's see this, right? So we sort by start time and we add this guy to our queue. We loop through our meeting list, which is this guy, starting with the second one. So if the end time of the meeting in the queue is less than the starting time of this, then it's not. Then we're gonna add this guy to the current to the current meeting that it's starting. Now our queue has 2. And now we compare what is higher, our counter, which was, we can start this at 1, or, yeah, that was a mistake. And we start this at 1 because we already have a first meeting on the queue, right? Or the length of the queue. So our counter is 1 and the length of the queue is 2. So then we update the max, the meetings happening. And then we return the counter. There is an edge case here. If the list is empty, if intervals length is empty, we return 0. And if the length is 1, then we're just not going to get into our loop, and we're going to return the counter, which is 1. So that's fine. So let's implement this and see what happens. All right. So let's just do this. If length of intervals 0, return 0. That's done. Okay. Done. So then what did we say we need to do? Sort. So okay, so we need to intervals sort, but this is a list of lists, so we need to tell it. See when it says here key, usually you don't need to say key if it's a string or if it's a number, but since it's another list, we need to tell it also what are you going to sort it by. And to do that, you set the key equals to lambda meeting m, whatever variable, m 0. So we're sorting by the first one. We're just telling it. This is a right? Yeah. So this is correct. Right. So now we need to, let's create a priority queue. So our queue and let's to deal with the priority queue, we're actually going to use a Python library that already has this implemented, which is called heap queue. Heap queue dot heap. Thought he was going to help me. Heap bash. And here we're just going to tell it which one, and then we're going to say what do we want to add it to. Intervals, we want to add the first one, but we want to add the end time. And here we can declare our meetings happening equals 1. So we have one meeting happening. Right, so we did this, then this, create a priority queue. Okay. Now we're gonna for meeting in intervals, starting with the second one, right? Almost there. So if, yeah, so this is what is where it gets interesting. So we're gonna, if whatever is on the top of our queue, which is the end time of the last meeting that started, is less or equal to our meeting start time, then heap queue dot heap. So I can do that. Heap pop queue. Heap pop heap queue heap pop. Yeah, I don't need. Yeah, I don't know what I was thinking. Yeah, if pop, you're always popping the top one. So if the top one is less or equal, that means that the meeting is over, so I can take it off my queue, right? And in here, I'm just gonna add the current one, heap push queue meeting one, right? Yeah. So we did this. We did this. Add the current one. Okay. Yeah. Now we're gonna compare. So now, oh, it's here. So now we need to meetings happening equals max meetings happening length of queue. And then we return our meetings. Actually, this should be called max meetings happening. But for the sake of this exercise, so this should be good. Let's try to run and see if I didn't make any mistakes, which I usually do. No, I didn't. Doesn't look that. Looks like it. Let's deliver. All right, accept it. First try. Awesome. Faster than 68%, which is not horrible. One thing that we should know here is that if we're using the heap queue, so this takes log n. This takes a log n. This one is basically O of n, where n is the number of meetings. It's n minus 1, but that doesn't really matter in this case. And so at the end of the day, this algorithm would be, the time complexity of this would be O n log n, because these three guys, you kind of use them twice in here sometimes. You're not gonna call this guy every time. Not this guy, you're gonna call it every time. But it doesn't really matter if there's a constant in front of it. So you eliminate everything, and at the end, this is n log n. And that's it, guys. That's it for today. I hope you guys enjoyed this one. See you next time.